Welcome to the Deep Dive, where we take a stack of sources and try to distill them into the most important nuggets of knowledge for you. Today, we're kicking things off with a quote from Satya Nadella, the CEO of Microsoft. He said, "When you have data in silos, when it's duplicated, you can't drive insight. AI amplifies this chaos unless you clean it first." And that quote, well, it perfectly sets the stage for our deep dive today into data deduplication. It's often seen as this, back office tech thing, just an optimization.
Right, just about saving space.
Exactly. But as Nadella points out, especially now in the age of AI, it's becoming just mission critical. So our goal today is really to unpack why people are starting to call deduplication the new data privacy. We'll look at how its impact goes way beyond just storage efficiency. We're talking about ethical AI, bias mitigation, fair model training, robust data governance, all that good stuff. And we're drawing from a whole stack of sources that really get into the why and the how here.
Yeah, and what's really fascinating, I think, is how the role of deduplication has just fundamentally shifted. Like you said, it's not just about saving disk space or making queries faster anymore. Not in the AI era. Now it's foundational. It's about data accuracy, preventing model overfitting, keeping those data governance frameworks strong. It's sort of baseline stuff now.
Right, because if you think about it, if your training data for an AI model has duplicates, you're essentially feeding it the same facts over and over again, which makes the model think that piece of info is way more important or more frequent than it actually is in the real world. And that can lead to some pretty serious problems, can't it?
Precisely. Yeah, duplicated data leads directly to skewed training data, no way around it. And this can cause what we call false confidence in AI models or even overfitting.
Overfitting. That's where it gets too good at the training data but fails on new stuff.
Exactly. The model learns the training data's quirks, including all those redundancies, instead of the actual general patterns you want it to learn. So your AI becomes brittle, less adaptable when you put it out in the real world, leads to unexpected failures. And if you connect this to, say, large language models or really any AI system, it just boils down to that core principle. Garbage in equals hallucination or poor predictions out.
Yeah.
The quality, the uniqueness of what you feed it, that directly dictates how reliable the output is going to be.
Okay, so we definitely get why it's so crucial. But the challenge then becomes, how do you actually find that garbage? Because like you hinted, duplicate isn't always just, hitting copy-paste. Sounds like there are different kinds of duplicates.
Oh, absolutely. Different flavors for sure. The simplest kind is an exact match. That's where records are completely identical, byte for byte. For those, you've got your basic tools like SQL's row number function or Spark's drop duplicates. They're pretty standard.
Simple enough.
Yeah, they're efficient. But you got to understand their limits, right? They won't catch anything unless it's a perfect identical match.
So two identical customer records side by side, they'll nab it. But what about when things are fuzzier, like those near duplicates you mentioned?
Yeah, that's where it gets really interesting and frankly more difficult. Near duplicates are texts usually that are slightly different. Think variations in emails or names, like John Doe versus John Doe.
Oh, right. Simple typos or variations?
Exactly. But they aren't just typos in terms of impact. If you don't deal with them, they can create totally separate entities in your data set. So you end up misrepresenting your customer base or, other critical data points. For these, you need smarter tools. Things like Spark's Fuzzy Wuzzy library, or calculating Levenshtein distance, or in Snowflake, you've got functions like soundex and difference.
Okay, let's dig into that John Doe example a bit more. Say you have records for John Doe, John Doe, John Doe, and maybe Jane Doe. How would soundex and difference help sort that out?
All right, good example. So soundex basically converts a name into a phonetic code based on how it sounds.
Yeah.
So John and John, they sound the same, right? They'd likely get the same soundex code.
Okay.
Then difference compares two of those soundex codes and gives you a score usually 0 to 4. 4 means they're phonetically identical or very, very close. So in your list, John Doe compared to John Doe, they probably both get a 4 compared to, say, a target John Doe. They sound alike.
Makes sense.
John Doe with the H, they might get a 3. Still very close phonetically.
It's pretty similar.
But Jane Doe, even though Doe sounds like Doe, Jane sounds nothing like John. So maybe that only gets a score of 2. And you can set a threshold, like say, only count scores of 3 or 4 as potential duplicates.
I see. So you filter out the ones that are clearly different, like Jane.
Exactly. It lets you programmatically find those near misses that a simple exact match would just sail right past. It stops you from creating multiple profiles for what's actually the same person or thing. That's huge for accuracy in analytics, or you're not sending someone duplicate emails.
That is incredibly clever for names, addresses, short strings like that. But what about longer text, where the meaning matters more than just the spelling or the sound? Especially thinking about AI and LLMs here.
Yeah, that's the next level. That brings us to vector-based deduplication. This is really where AI meets data quality head-on. Instead of just comparing character strings, we're operating in, well, you could call it a semantic space.
Semantic space.
Think of words or even whole sentences as points in this huge multidimensional map. Vector embeddings plot these points based on their meaning, not just the letters they contain.
Okay.
So words like car and automobile, even though they're spelled differently, might end up plotted really close together on this map because they mean basically the same thing.
I got it. Based on meaning.
Right. And this lets us find near duplicates based on semantic similarity, which is like absolutely non-negotiable if you're working with sophisticated LLMs. It involves turning text into these complex numerical representations vectors and then using vector databases or stores, things like Face or Chroma in Databricks, or maybe the similarity join function in Snowflake, to find vectors that are mathematically close. Close vectors mean similar meaning.
Wow, okay, that's a big leap. So let's get practical. How are companies actually doing this stuff, putting these strategies into action?
Well, starting with the basics, for SQL-based deduplication, like in Snowflake, a common pattern is removing duplicates based on key columns, but making sure you keep the latest record. You typically use that row number function again, but this time with partition by your key column, maybe use a RID, and then order by a timestamp, descending. So rank 1 is the newest. Now you just keep rank 1.
Right, keep the most recent version.
Yeah. And this is also where you could apply that fuzzy logic we talked about, maybe writing a query to find names where the difference score between them is over, say, 3. It's like layer 1, an essential first step, but definitely just one tool in the box.
And what about in the PySpark world, maybe using Databricks?
PySpark has similar basics. Sure, you can do that same row number dot over window dot partition by logic pretty easily. But where PySpark, especially combined with the Databricks ecosystem, really shines for AI is with that text semantic similarity, often using Hugging Face models.
Okay, yeah, you mentioned embeddings. This sounds like where it gets really powerful. Tell us more.
So you use models, often things called sentence transformer models, from libraries like Hugging Face. These models take a whole sentence or even a paragraph and convert it into one of those high-dimensional vector embeddings we talked about, a list of numbers that captures the meaning.
Okay, so text becomes numbers representing meaning.
Exactly. And once you have these vectors for your different pieces of text, you can calculate something called cosine similarity, or a cosine score between them. This score goes from 0 to 1.
Yeah.
1 means the meanings are identical. 0 means they're totally unrelated.
Higher score means more similar meaning.
Right. So you might set a threshold, maybe 0.95 or higher. If two sentences have a cosine similarity above that, you treat them as near duplicates, even if the words are quite different.
Like the cat sat on the mat versus on the rug, the feline rested.
Precisely. Those might have a very high cosine score.
Yeah.
And this is just absolutely critical for training good LLMs. It stops them from just memorizing slightly different ways of saying the same thing. It forces them to learn more generalizable concepts because they're seeing more unique ideas.
That makes a ton of sense. It's way beyond just keyword matching. Okay, so moving on from finding duplicates. What are companies doing to build like really future-proof AI pipelines with this stuff? Some advanced practices.
Yeah, definitely. One big area is streaming deduplication. Super important. This is all about making sure your real-time data pipelines don't accidentally process the same event twice. Think clicks, transactions, sensor data.
Stuff coming in really fast.
Exactly. You see this a lot with tools like Databricks, Delta Live Tables, they call it DLT. They use merge statements to handle incoming data streams. Or in Snowflake, you might use Snowpipe for ingestion, again, often paired with merge logic, to avoid inserting duplicates or reprocessing updates. It's vital for applications where every single event needs to be unique and counted correctly, like right now.
So stops double counting clicks, or worse, double charging someone in real time. Okay. What about just making sure every single row of data is unique, even if you don't have a nice, clean primary key to check against?
Good question. That's where metadata deduplication using hashing comes into play. The idea is to use a hashing algorithm, common ones are MD5 or maybe SHA2, to create a kind of digital fingerprint for the entire row's content.
A fingerprint for the whole row.
Yeah. So in PySpark, for example, you might do something like MD5, concats, df.columns. That takes all the column values, strings them together with a separator, and then calculates the MD5 hash of that whole string.
Oh, okay.
If two rows have the exact same data across all columns, they will produce the exact same hash value, guaranteed. So it lets you spot exact row duplicates, even if you don't have a reliable unique ID column to check.
That seems really useful for messy data.
Hugely useful,
Yeah.
especially if schemas change or you just lack a good natural key. It gives you an immediate way to flag any identical row content or even detect if a row's content has changed by comparing hashes over time. Snowflake has similar functions, like MD5 to Varchia, to achieve the same thing.
Very clever. A really robust way to check integrity and pushing the semantic idea further, beyond just text.
Right, for true semantic deduplication across different types of data, you're embedding text, but maybe also images or even video clips. Then you compare these embeddings using vector similarity search. This uses specialized databases or libraries like AES, ChromaDB, or maybe pgvector if you're in the post-Oracle world.
And this is big for ARG, you mentioned, retrieval augmented generation.
Absolutely critical for AG. Think about it.
Yeah.
Your LLM retrieves relevant documents to help answer a question. If your document store is full of semantically identical articles, just worded slightly differently,
It might retrieve redundant info.
exactly, or slightly conflicting info from near duplicates. Using semantic deduplication on your source documents before you build the RG index ensures the retrieved context is cleaner, more diverse, and less likely to cause the LLM to generate repetitive or hallucinatory responses. Tools like ChromaDB are built specifically to store these vectors and find similar entries efficiently.
So it cleans up the source material for the AI. Makes sense. And what about way upstream? Before data even gets close to training an ML model, how do we make sure it's clean right from the start?
That brings us to ML model training data validation. This is about setting up guardrails, like checkpoints, before your main ML pipeline even kicks off.
Like a quality check.
Precisely. A popular tool for this, especially in the Databricks world, is Great Expectations. It lets you define expectations or assertions about your data. For example, you can assert that your recorded column must contain unique values, or that your target variable, the thing you're trying to predict, has no missing values, which is often absolutely crucial for ML algorithms.
Right. Can't train if you don't know the answer.
Exactly. Or you could check that certain feature scores are within a reasonable range, like a probability score should be between 0 and 1. This helps catch data drift, schema changes, or just plain data corruption really early. It stops bad data from ever poisoning your model training process.
It seems like deduplication in all these forms really isn't just a minor technical detail anymore. It feels like it has this massive ripple effect on, well, everything AI.
It absolutely does. When we talk about governance and AI reliability, deduplication is right there at the center. It's fundamental for model integrity, like we said, preventing skewed training due to overrepresented data points.
Yeah.
That leads to fairer, more robust models.
Fair. Okay.
For explainability, having cleaner, unique input data makes tracing the lineage from raw data to the final model prediction much easier. Your audit trail is clearer.
Less noise in the system.
Exactly. And just pure. Performance, smaller, cleaner data sets mean faster training, faster retraining, faster inference when the model is actually running. It saves compute time and cost.
So it really hits trust, efficiency, reliability, the whole package. What does this mean for building AI systems that are, future ready?
Well, for future-ready AI, it means fully embracing these techniques, especially things like semantic embedding comparison that's key for LLM safety and accuracy. It means needing robust support for vector databases, whether it's FAI, SS, Chroma, Pinecone, or native features like Snowflake's vector search. That's becoming table stakes. It also means thinking about uniqueness in your prompting pipelines. If you're crafting prompts dynamically, ensuring uniqueness can help avoid weird issues like prompt injection, where maybe a repeated pattern tricks the model.
Interesting security angle, too.
Yeah. And like we discussed with RAG, it's critical for AI agents and retrieval flows to prevent those hallucinations that often stem from feeding the model redundant or contradictory information from its knowledge base.
Okay, so let's bring it back home. What does all this really mean for you, the listener? Why should you care about these technical details?
Yeah, why does this matter for you? Well, think about an AI recommending products or news articles or even healthcare treatments. Imagine if, due to poor deduplication, the AI sees multiple slightly different records for the same user interaction or the same patient case. It might wrongly conclude that a certain product preference or medical condition is far more common than it is.
Giving it a false sense of importance.
Exactly. The AI becomes confident, but confident in the wrong patterns. This leads to skewed recommendations, maybe suboptimal medical advice, potentially even harmful outcomes in critical applications. Duplicates in your AI and ML pipelines directly cause skewed training data. That leads to false confidence, overfitting, all the problems we mentioned. And especially with LLMs and embeddings, you absolutely need that semantic level uniqueness. So circling back to that core idea, garbage in equals hallucination or poor predictions out. Your AI's ultimate reliability really hinges on the cleanliness and uniqueness of the data you feed it.
But this isn't just theory, right? We actually have some great examples of big companies putting these exact deduplication strategies into practice.
Oh yeah, absolutely. Real-world stuff. Take Airbnb. They use streaming deduplication, reportedly with Databricks Delta Live tables, to make sure they don't get double bookings. They deduplicate guest reservation logs as they come in real time. That's critical operational integrity for them.
Makes sense. No one wants two guests showing up for the same room.
Definitely not.
Mm-hmm.
Then you have PepsiCo. They use metadata deduplication, that hashing technique with Snowflake. They use MD5 hashes, apparently, to spot duplicate product entries when they're ingesting data for their global product catalog. Keeps things accurate.
Okay, catalog consistency. And what about finance? That seems like a place where duplicates would be a huge problem.
Oh, absolutely.
Mm-hmm.
Think about Goldman Sachs. In high-frequency trading or even just regular portfolio management, a single duplicated transaction record could be disastrous.
Yeah, I can imagine. Mess up risk calculations, portfolio values.
Regulatory fines, you name it. So they heavily leverage ML training validation using tools like Databricks and Great Expectations to ensure their financial transaction data is unique and clean before it ever feeds their trading models or risk systems. It's about preventing errors before they happen.
Preventing multi-billion-dollar mistakes, potentially.
Potentially, yeah. Then on the content side, think LinkedIn. They reportedly use semantic deduplication, maybe with FAIs and Databricks, to find similar job postings or detect spam content. They're comparing the meaning of posts using embeddings.
Finding near-duplicate job ads or spammy posts?
Exactly. And Spotify does something similar, apparently also using Databricks for semantic deduplication, but for audio and text. Filtering out near-duplicate songs or podcast episodes using embedding matching so your recommendations feel fresh.
That's fascinating, using it across different media types.
Yeah. And what's really telling is that most really large companies, think JP Morgan Chase or similar, they don't just pick one technique. They typically combine multiple layers, streaming, dedupe, metadata hashing, semantic checks, pre-training validation. It's a layered defense strategy.
A multi-pronged approach.
Right. To build truly trusted data pipelines, and importantly, to meet all the strict regulatory compliance rules they operate under. It shows this isn't a one-size-fits-all problem. You need a comprehensive toolkit.
So as we wrap up this deep dive, it seems crystal clear that deduplication in this AI-first world has really, well, it's graduated. It's not just a back-office cleanup task anymore. It's genuinely a strategic enabler. It underpins trust, speed, reliability, and pretty much any data-driven decision.
Foundational.
Whether you're training an ML model, running real-time dashboards, deploying a chatbot, duplicates can just inject errors, bloat costs, and really undermine how much you can rely on the output.
Yeah, we've touched on quite a few angles. Streaming, metadata hashing, the whole semantic embedding piece, ML validation checks. Hopefully giving a sense of the technical depth, but also the practical side.
Definitely. So let's leave you, our listeners, with maybe a final provocative thought to chew on. As AI gets woven deeper and deeper into everything we do, from the shows we watch to how our money is managed, to maybe even medical diagnoses, how is this increasing reliance on truly clean, deduplicated data going to shape the future of innovation? And maybe more importantly, what responsibility do we all share as technologists, as businesses, as users, to ensure the integrity of the information that's powering these increasingly intelligent and increasingly influential systems? Something to think about. That's all for this deep dive. We hope you feel a little more well-informed. Thanks for listening.